Hello and welcome to another video. In this video we're going to be doing problem 3043, find the length of the longest common prefix from this week's weekly contest. In the problem you're given two arrays of positive integers r1 and r2, and a prefix of a positive integer is an integer formed by one or more of its digits starting from its leftmost digit. So similarly to a string prefix, it's just essentially some kind of starting numbers of the number. So like for this, 1, 2, 3 is a prefix, 2, 3, 4 is not, because it's a start with a start. Common prefix is an integer such that C is a prefix of both A and B. So for example, if we have these two numbers, they have a prefix 565. And like I said, literally you can think of these as just being strings instead of numbers, and it would be the same thing. You need to find the length of the longest common prefix between all pairs of integers such that x belongs to r1 and y belongs to r2. Return the length of the longest common prefix. If there is no common prefix, return 0. And the big thing here is this is a 5 times 10 to the 4th for each array. So we can't just like try all pairs, right? We can't just be like, okay, let's just like get all combinations. We can't do that. So we have to do something else. So in this example, they show you there's 3 pairs. So the longest common prefix of 1 and 1,000 is 1. The longest common prefix of 10 and 1,000 is 10, and 100 and 1,000 is 100. Longest common prefix is 100 of this and this. And in the second example, there is no common prefix, so you return 0. So essentially, we want to figure out how to get this down from like n squared to order n. And because we can't compare every number to every other number, what we can do is we can take all of one of these, one or the other, and get every single prefix possible. So like we can take this array, get every single prefix possible, turn it into a set for O of 1 lookups, and also have a count for those. So we can have a actually we don't need a count. We're just concerned with, like, we don't care about how many prefixes. We're just concerned with how big the prefix is. So we can have all the prefixes in here that are possible, and then for every number here we can just go through like, okay, what are all the prefixes possible and what's like the best result. So let's kind of walk through how it would work for this problem here. So if we have 1, 10, and 100, what we want is every prefix possible. So in here, this is shown, but let's just say this isn't 1, 10, and 100. Let's say it's like 9, and then maybe like 89, and then 100. So how do we get every prefix? So it's pretty easy. For this number 9, we can basically just start with every number. So let's say we start with 9, and then we can just keep taking the number and keep getting rid of the last digit. And that would give us every prefix possible. So for example, let's just say we have some big number. Let's just say we have like 8, 9, 5, 7, 9. So all of the prefixes here are this whole thing. Or we can get rid of this number and it would be this. Or we can get rid of this number and it would be this. Get rid of this number, it would be this. Get rid of this number, it would be this. So all of the prefixes here are either this, or this, or this, or this, or the whole thing. And so that's what we can do. So we can just walk through this problem now. So, and then we can store our prefixes in a set. So for 9, we're going to say, okay, while this number is not 0, let's just keep taking the current number and add it to our prefixes. So 9 is a prefix of 9, so we will add 9 into our set. Then we will divide by 10 to get rid of the last digit, so divide by 10. And we get 0, so there's nothing else for this number. So then for 89, so 89 is a prefix, so we'll put 89 into our set. And then we will divide by 10, we'll get 8. And then 8 is also a prefix, so we will put 8 into our set. And we'll divide by 10 and get 0, and we're done there. Then 100. So for 100, 100 is a prefix of 100, so we will put 100 into our set. Then we will divide by 10, so get 10. Then put 10 into our set. Then divide by 10, get 1. Put 1 into our set. And divide by 10, get 0. So these are all of the prefixes possible out of all these numbers. And we're going to have a set for O of 1 lookups, and so we don't have duplicate values. Then for this number 1,000, we can just check, like, is this 1,000 in here? So is 1,000 in here? No, it's not. That means if this isn't in here, we'll try something shorter. So we'll try 100, right? Because all the prefixes are just every number minus something from the end. So we will divide by 10, And we'll say, is 100 in here? 100 is in here, so this is a match. So now you can do this a few ways, but I use numbers. Now you want to figure out, okay, is this a match? How long is this actual prefix? Like how many numbers is 100? And the way I did this personally, and you can do it whatever way you want, you can actually make strings, is I just used a log function. So I just use a log base 10. So if you have a log function, if you have like 10 to the x equals 100, that means log of 100 will be 2, right? Because 10 squared is 100. So log of 100 will be 2. And then basically, if this log value, if this log base 10 is a whole number, the number of digits is going to be whatever it is plus 1, right? Because it'll be a complete power of 10. So like 10 cubed is 1,000. So log of 1,000 will be 3, but it's 4 digits. But if you do log base 10 of like 900 or something, it will be 2 point something, right? Because log of 100 is 2, log of 1,000 is 3. So it's going to be between those two values. So it'll be 2 point something. So basically what you can do is you can just take the log of your number, and if it's a whole number, you add 1 for the digits. And if it's not a whole number, you just round up. So if, like in this case, if we do log of 900, it will give us 2 point something, we'll round up to 3. But if we do log of 1,000, it will give us 3, like a full number, so we'll round up to 4. So that's how you can tell quickly how many digits are in your number, or you could like turn it into a string, I guess, too. But I just use log. If you want to, though, instead, you can obviously just use a string instead. I just happen to use logs. I'm not exactly sure why. Just something different, but you can just turn your number into a string and figure out how many digits it has as well. But regardless, once you figure out if there's a match, so let's say 100 is a match, which it is, now we can record, okay, we found a prefix of length 3, and we never need to check any smaller prefix, right? So we're going to start with our full number, 1,000, and we're going to check, does that prefix exist? And if it does exist, then there's no point in checking like 100 because it's going to always just get shorter, right? We'll try 1,000, then we'll try 100, then we'll try 10, and so on. So the basic idea is you start with your number, you check if it's in your set of prefixes that you made. If it is, you're done with that number, just store the length. And then whatever prefix has the biggest length out of all the numbers in array 2 that you found is going to be your answer. So we can take a look at the code. So I basically made a set of prefixes, and then for every number in array 1, I just said while the number is greater than 0, just keep adding the number and keep dividing it by 10 to get every single possible prefix possible. Then we have a result, and for every number in array 2, while that number is greater than 0, check, is it in there? If it is, then we are done here. And so I use a little trick here. Instead of, I remember I said that a log base 10 of so if we do like log base 10 of 100, this will be 2, but we really want 3. So what I did is I took whatever number I had, I took the log and I just added a really small value, and then I did the ceiling. That way I would never get a full whole number. I mean, I guess technically you could. Actually, no, you can't. Yeah, you can't. So you can, but you'd have to get a number that would have rounded up here. So to get a full whole number here, let's say to get a 3, you'd have to have like 2.9999999, which would be rounded up to 3. But if you have 3, because you added this, it would round up to 4. So little trick, like I said, if this is a little weird, you can just take your number and turn it into a string and get the length. But essentially, I just said, okay, let me figure out how many digits are in this prefix by doing this, right? You take the log base 10, you do this little trick to get the powers of 10 up one value, and everything else will work correctly. And then you basically just, if this was a prefix, right? So like I said, if our current number in array 2 is 1,000 and we found 100, we don't need to check like 10 and 1 and so on, because 100 is longer than all of those. So if we did find a match, just break. Otherwise, divide that number by 10, keep checking for the next prefix. And finally, I believe they ask you to return 0 if there were no matches, so I just have it default to 0. Like I said, this is a little weird. You can't just turn your number to a string, but that's the main idea, is you can't have an n-squared solution, so you just have all of the prefixes from array 1 or array 2, whichever one you prefer, and then you go down the other array, you get all the prefixes there, and then you do O of 1 lookups to see if that prefix is in the other array. Now you can do this using a try as well, but I just didn't think of a try. I thought of this pretty quickly, so this is the solution I went with. So we can submit. You can see it's pretty reasonable. So this is basically going to be time of n. So the log is technically like logarithmic, obviously, but because the numbers aren't super big, like the numbers are only 10 to the 8th, a log of a number will be at most like 8 operations, so it's basically O of 1. So time is O of n, and space is O of n, because for every number there can be up to like 8 prefixes or so. So it's like, so that's O of n. For every number in array 1, there can be like roughly 8 unique prefixes. And yeah, it's going to be all for this one, so hopefully you liked it. Like I said, if this is a little weird, you can convert your number to a string. You can use a try many different ways, but the idea is this is how you get the prefixes and this is how you check. And you can just handle it using a string or something else if you want to. But yeah, that's going to be all for this one. Hopefully you liked it, and if you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.